So for today's fantastic lesson, we're going to take a look at transformations. So transformations of functions is the heading of today's lesson. So the learning targets are going to be being able to describe transformation. So how does it shift left, right, up, down, reflections, and then also be able to rewrite the actual function itself, what that transformation function would look like as an equation. And then lastly, being able to graph these transformations. So we had a little Desmos activity that hopefully allowed you to explore how we shift things left, right, up, down. But these are all the rules of the transformations of functions that we'll come across in math. Okay, and so take a moment, make sure you have these written down somewhere in your notes. But for the first one, if you ever see a constant sort of outside the function where it's described f of x, and then we have this plus or minus c on the outside, in those cases, those shift up or down in whatever that value is. So if you see plus 5 on the outside, that would mean shifting up 5 units and so forth. If you ever see a transformation embedded in parentheses, it shifts it left or right, but it's sort of opposite of how we think of things. So if you think of inside, it would be f of x plus 3. That would actually shift left 3 units. And if it was minus inside, so x minus 4 or something like that, that would be right 4 units. So with the middle part, you just want to remember that it's opposite the sign. And so we also reflect things across either the x-axis or y-axis. And so if you see a negative value on the outside of the function, that's a reflection specifically over the x-axis. And if you see it inside the parentheses where the negative is still in front of x, but inside the parentheses, that's a reflection over the y-axis. So make sure you have some time to copy these down in your notes because we're going to be taking a look at not only describing but also writing them on the next few slides. So let's take a look at this example together. It says describe the transformation and rewrite the function transformation. So let's go through and describe each one of these. So if you look at your notes, notice in the first case we have f of x plus 9. And remember, anytime you have a constant value on the outside, that shifts it up or down. And so in this case, since it's positive 9, that would actually shift the entire function up 9 units, we'd say. In the middle one, notice it's in parentheses. Anytime it's in parentheses, that's left or right. But remember, it's opposite. So if you see minus 4, that actually shifts it right by 4 units there. And the last one has a couple things going on here. In fact, we see that minus 2 on the outside. And so remember, that's up or down. And so since it's minus 2, that would be down 2 units. But we also see this negative in front. And so remember, if you see a negative, that's a reflection. And specifically, since it's in front of the function, we're going to say reflection across x-axis here. If it was inside, if you saw the negative inside there, that would be y-axis. So now we're going to take a look at writing each of these now. So in the first case, it says we take f of x and we add 9. Well, f of x is given. Notice the f of x here, that's this equation, 3x minus 10. And so what we're doing in the first case is we're taking that entire f of x, which is 3x minus 10, and we're just adding 9 to that. And so if I simply collect like terms here, looks like 3x minus 10 plus 9 would be 3x minus 1, and that would be our new transformation function. Notice in the next case, we have f of x minus 4, and when it's inside, we call that a composition. And so remember with these, that means you're taking that entire x minus 4, and you're plugging it directly in for x there. And so instead of x, we're going to be replacing x with that x minus 4. And so in this case, to simplify, I would distribute the 3 through. So it become 3x minus 12, and then we still have the minus 10 on the outside. And if I collect these last two terms, looks like I get 3x minus 22 would be that answer. And the last one has a combination where if you look at the first part, you're taking the opposite of the function. So I'm putting a negative in front of the entire function itself, and the function that we're looking at is 3x minus 10. So that would be opposite of f of x, and then lastly, you're subtracting 2. And so if I get rid of this negative by distributing it through, it becomes negative 3x plus 10 minus 2. And collecting like terms, I get negative 3x plus 8 would be my overall final answer there. So let's take a look at a few more before I have you guys try some on your own. So here again, we have a different function to work on. So it's x squared plus 3 is what's given, and now we're going to describe first each of these. So notice in the first case, it's inside the parentheses, so remember it's left or right when you see that. And so since it's plus 2, remember it's opposite here. So in this case, we'd say left 2 units is what the first transformation would be. Notice the minus 7 and the next one is on the outside. And remember that's up or down. And since it's plus or it's minus 7 there, that sign tells you exactly the direction it goes. So down 7 units here. And the last one has a combination where we have inside the parentheses, remember that's left or right, but also we have outside constant here, up or down. And so remember it's inside the parentheses, it's opposite there. So in this case, since it's minus 1, that would actually be right by 1 unit. And then this plus 4, that would be up 4 units. So now let's take a look at writing each of these. So in the first case, if we were to write what the equation of f of x plus 2 is, remember again, that's a composition. And so for compositions, I'm taking that entire x plus 2, but I'm subbing it in, looks like 2 places here. I'm going to be replacing x with that x plus 2. And so originally it was x squared plus 3x, now it's going to be x plus 2 squared plus 3 times x plus 2. Now if you were to simplify this, in the first case you have to FOIL that, so that's 2 factors of x plus 2. And then in the next case, that next term, we have to distribute that 3 to get rid of it, so it becomes 3x plus 6. So if I FOIL that first term, looks like I get x squared, outside would be positive 2x, inside would be positive 2x, and 2 times 2 becomes 4. And then we still have the 3x plus 6 on the outside. And so if I collect like terms, there is no other x squareds, but all the x's, 2 plus another 2 plus 3 of them gives me positive 7x. And then looks like 4 and 6 become positive 10. And so that would be my final answer there. In the next one, if you're taking that entire function and subtracting 7 off, well, that's exactly what we're doing here. We're taking f of x, which is written right here. That's the x squared plus 3x. That's what f of x is, and we are subtracting 7 off of that. And so notice with this one, there is no other terms to collect, so my final answer would be x squared plus 3x minus 7. In the very last one, there's a combination of things. We're not only plugging in x plus x minus 1 in for x there, so just that first part would be, and again, you're replacing it with for x, so it would be x minus 1 squared plus 3 times x minus 1. And then we still have that plus 4 on the tail end that we have to drop there. And so in the first term, we'd have to FOIL that. In the second term, we can distribute that 3 through. And we still have that plus 4. And so if I FOIL the first 2 terms there, looks like it's x squared minus x minus another x, and then plus 1. And then if I collect all my like terms, looks like I get negative x minus x plus 3x. That's going to be positive x. And then if I collect all the constant terms, positive 1 minus 3 plus 4, that looks like altogether positive 2. So take a moment and see if you can write these now. Notice it's g of x, but you're focusing on just kind of doing that right operation here. So not only describe, but also see if you can write these transformation functions. You can pause the video, and good luck. So in the first one, if you were to describe, if you see that g of x is taking f of x and adding 5, that would be up 5 units. And so if I were to write this function, you're taking the entire f of x and adding 5. Well, f of x is x squared minus 4. And if I add 5 to that, then it'd be x squared plus 1. And that would be my final answer there. Here we have it inside the parentheses, so that's left or right, but since it's minus 3, that would be right by 3 units. So that's the describing part. And now if I were to write that function, notice our original function was x squared minus 4. So instead of the x, I'm going to replace it with the x minus 3 there, because that's again a composition. And so to simplify this, that means there's 2 factors of the x minus 3. And so if I FOIL the first, inside last, and collect like terms, I get x squared. Looks like negative 3x minus 3x is negative 6x, and then positive 9 minus 4 would be positive 5. And that would be my final answer there. So for part 2 here is we're going to be looking at graphing these transformations. And so when you're looking at graphing, a couple things to remember is first pick some points on the original graph. So it's always good to have at least 3 points to make up whatever function we're looking at. You're going to move those points based off the transformation. So if you see things shift left, right, or left 3, then you're going to be moving 3 to the left. If you're shifting it up or down, you're just moving those points accordingly to the transformation. And then lastly, you're connecting those points together to make it look like the shape of the original function, or roughly the shape of it. So let's take a look at graphing some transformations here. So here, notice we're given f of x equals absolute value of x. So the first step is let's get a sketch of what that graph looks like. And so if I were to sketch this out, maybe make a table of values, pick some negative and positive ones just to be safe. So I'm going to pick about 5 points here, but if I sub in negative 2 in for the absolute value of x, that's going to be positive 2. If I sub in negative 1, that's positive 1. If I sub in 0, it's 0, and 1 and 2. So if I plot those points, negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2, you're going to get this V-shaped looking graph that you might be familiar with absolute value of. And so now if I wanted to sketch the first one in green, remember that description, since it's inside the parentheses there, is right 1 unit. And so I wanted to take all those 5 points and shift it right 1 unit. And so this one would map to here, that origin point would map over right 1, that 1, 1 coordinate would map over to this point, and then that last one would map over here. And so this is what it would look like in green by shifting it all right 1 unit. Still maintains that shape. And so if I did the next one over, which is in red, that means I'm taking the entire function and adding 4. That means I'm shifting it up 4 units. And so if I take all those black points and now shift them up 4 units, up 4 would be to this one. That negative 1, 1 coordinate would shift up here. The origin would actually shift up 4 to being 0, 4 there. And then the rest of them, if I shift up 4, would look like this. If I take a look at the next one in blue, since there's a negative on the outside, remember that's a reflection, and specifically across the x-axis here. So when you're doing these ones and reflecting it about the x-axis, whatever's above the x-axis is now going to be reflected below. And so the origin is actually going to stay the same here because that's on the actual x-axis itself. But then this coordinate right over here, the negative 2, 2 would reflect down at negative 2, negative 2. The negative 1, 1 would reflect down below as negative 1, negative 1. And then the other points would also reflect down below. And so you sort of get that upside down V-shape graph there. And the last one, if I did it in purple now, so if I did the next one in purple, there's a couple things going on. Not only are you reflecting it, so that'd be reflection across x-axis, but also you're shifting it left 2 units and the outside -1 would be down 2 units. So let's first maybe do the slide transformation here, left and down. And so from that black graph, if I shift everything left 2 units and down 1, this very left point would go left 2, down 1 to here. The -1 point would go left 2, down 1. That would be on the x-axis. The origin, if I shifted it left 2, down 1, would be at -2, 1. The 1 point, left 2, down 1, would be on the x-axis there, and the last point, left 2, down 1, would be right there. But we're not sketching that. We're actually taking all those and now reflecting it. So if I reflect those about the x-axis now, notice there's a couple points that are going to remain that are on the x-axis. But this point would now shift below, and this would reflect above. And so it's kind of hard to see here, but I believe it should look something like this in purple. So it's a combination of not only shifting it left 2 and down 2, but also reflecting it after that. So let's take a look at a couple more sketching here. Here we're actually given the graph of f of x in blue. And so you can see it's a sort of a piecewise looking graph. In the first case, you're adding 1 to it, which remember would be shifting up 1 units here. So if I do that in red, or some key points I can kind of target here, all these vertex points. And so if I shift the first one up 1 unit, that's going to be up here, because remember these are going up by 2s, it looks like. And so shifting it up 1 unit there on the y-axis would map to here, shifting that peak up 1 unit, and then the coordinate 4, 0 up 1 unit. And copying that sketch of what it looks like, you get something like this. And so the last one, if I were to do it in green now, remember it's inside the parentheses, so in that case it's going to be right 2 units, and so I need to take those key points and shift them right 2 units. So this point would be mapping to 0, 4. This lower point, it's going to be shifting right 2 units. The high point is going to be shifting right 2 units, and then this point is going to shift right 2 units. So if I copy that graph of what it looks like that in green. So take a moment, make sure you try the problems on today's practice on Canvas. Make sure you check in your answers. There's a backside to the practice which has some sketching type questions, so try your best on those. But don't forget to submit the homework quiz before the end of the day. And that's it for today's lesson. So you guys enjoy the rest of your day.